Hey guys, welcome back. We are on part 3 of solving absolute value equations. We're going to pick up with number 14. Part 2 ended with 13. Again, we're trying to isolate the absolute value before we do anything. So looking at 14, I'm going to work to get my absolute value alone. So to start, I'm going to add 3 to both sides. I get negative 80. Bring down the rest of my stuff. My absolute value is not isolated. What I need to do is get rid of this negative 10, so I'm going to divide by negative 10. Now, my absolute value is isolated. There's nothing around it, nothing underneath it, nothing before or after it. So now I can take the absolute value bars off and setting it equal to 8 and negative 8. So I have h plus 5 equals 8. H plus 5 equals negative 8. And now we're going to solve. Subtract 5 from both sides. H equals 3. So let's subtract 5 from both sides. H equals negative 13. So my solution set is H equals negative 13 and positive 3. All right. Looking at 15, I have to do 2 more steps again. I need to get rid of this negative 6 and this 7. I need my absolute values to be completely by themselves. So I'm going to add 6 to both sides, starting there. 7 times the absolute value of 4n plus 8 equals 112. Divide by 7. Cancels these guys out. You got your absolute value of 4n plus 8 equals 16. There's nothing before, after, or under the absolute value, so it is isolated. I am good to go. So I'm going to break them off into 2 separate equations. 4n plus 8 equals 16. 4n plus 8 equals negative 16. Both of them require 2 steps. So we're going to subtract by 8. This is digging back to unit 1, inverse operation. 4n equals 8. Divide by 4, n equals 2. The second one we're going to subtract by 8. 4n equals negative 24. Divide by 4, n equals negative 6. So make sure you guys can see that at home. Yes, we are good to go. Good. So my solution set for this one, n equals negative 6, positive 2. All right, number 16. We're going to start peeling away because we need the absolute value isolated. So I'm going to add 24 to both sides. Bring it down. I've got 3 over here. Got my absolute value, my 3 halves out front. 4r minus 4 inside that absolute value. We're going to multiply by the reciprocal of 2/3. These guys cancel out. Absolute value of 4r minus 4 equals 2. Absolute value is isolated. Now I can break it into 2 separate equations. So 4r minus 4 equals 2. 4r minus 4 equals negative 2. Solving them separately, getting 2 different solutions for my solution set. I'm going to add 4 to both sides. Divide by 4. It's a lot of 4s. If you type this in your calculator, most of you guys have an ABC button or an N over D button. Type this in as a fraction, hit enter, and it'll simplify it for you. It'll simplify it to 3 halves. That's one of my answers. And it's okay that it's a fraction. A fraction is a rational number. We get real numbers, and rational is real in Algebra 1. So fractions are okay. Plugging this, you could plug this back into the original equation and find out that it is true. You can always check your work. That's how you'll know you'll get 100% every time. Let's solve this equation. Add 4 on both sides. That'll cancel that 4 out. 4r equals positive 2. One more step. Divide by 4. R equals 1/2. So my solution set here is 1/2 and 3/2. Take a moment, let that process. We're going to switch to the bottom part of these notes. This is a special case. This is something that we need to be aware of. If we know the definition of absolute value, it is the distance a number is from 0, and you know that the absolute value is always positive. That's going to help you here in this case. There are a few times that you will see this special case arise. So we have the absolute value equals -6. Whenever we take the absolute value of any number, it's always positive. So in this case, no matter what number I put in for x, I'm not going to get a negative number. Therefore, there's no solution to this. Or you'll see this symbol as like an empty set. You can't put any number in for x that will come out as a -6 because the absolute value of any number is always positive. So looking at 18 again, we're going to isolate that variable. So I'm going to divide both sides by -3. Okay, no matter what number I put in there, it's telling me that the absolute value of that is going to come out as a -7. Again, that's not possible. That's a no solution. You have to get your absolute value totally isolated before you can make that decision. If you're looking at your practice, number 10 is a good example. It equals -5. You can't make that judgment until you add that 8 to both sides. And then you see that it becomes a +3. Or even number 16 here. This is a -21. But before we can make the judgment of no solution, we had to add the 24 and multiply by the reciprocal. We found out that it ended up becoming positive. So you have to get the absolute value totally isolated before you can make that decision of no solution. So my explanation here is the absolute value cannot equal a negative number once isolated. This is key. That's what I was just referring to there. Once it's isolated. 16 is a perfect example. Right now it equals something negative, but once we isolated that absolute value, it ended up becoming positive. Therefore, we could solve it. This is part 3 of solving absolute value equations. Mrs. Straight signing off.